Thank you. Um, we'll do a quick introduction. My name is Jack. I guess that's in the slides, isn't it? Whoops. Going this way. Okay. So my name is Jack. I am the product manager for the team, and I have with me here.
I'm Michael Huntman. I am a backend developer for the team.
Awesome. And so our project was a new Pi P3DB. Basically, so our sponsor was Dr. Yao. He is part of the School of Computing here at the university, and he works in his own lab called IDLE, so Integrated Digital Omnics Lab. They're a bioinformatics research group in the School of Computing, and so they're interested in different scaling algorithms involving different tools and databases to integrate different plants and proteins and modifications, and a bunch of biology stuff that I'm not familiar with. But our project was working on creating a new website for him. So a couple of ancillary individuals. We have Dr. Kim Yao himself. He's here with us today in person. Bill was our project manager. Brady is our tribe lead. Brad was our coach. And then, as we introduced before, my name's Jack. Michael, Todd, Jiwon, and Aryan are not currently with us. We also had another student on our team, Lin Han. He's not a part of the team. He graduated in the fall last semester. So I'll let Michael talk
All right,
about
so I'll talk about the problem and opportunities. So some of the problems we ran into. So the previous version of the site, the database that they had various types of data for protein modification and dynamic numbers of specific species, and they weren't able to host that all effectively in the scientific data sets. It also lacked functions for automatically adding, updating, and removing data sets. And so the user center that they had was considered insecure with the current PHP and MySQL implementation. And another problem was the Angular framework. It was fancy, but the deployment was complex, and the data wasn't as readable as they wanted it to be. And 5, it was hard to support quantitative data and unstructured data types. So for our solution built, we have a few different parts here. So for the front end, we used HTML, CSS, along with Bootstrap. The back end included MySQL, MongoDB, along with some other tools like SQL Alchemy and Django. And then for development operations, we had Travis CI for continuous integration.
Going further into that, so most of the project is based around Python. That's what we used as the main framework for our project. Django was the web framework that we used to actually host the site. So Django works by connecting HTML to the actual Python to integrate those functions to the site. And then we had our Conda, and we had our project in a Conda environment, which is essentially just a development environment that allows you to keep all the dependencies within one location. And it makes the project easily transportable so that anybody who has access to the project can download it and work on it just the same as everybody else would. And then other dependencies Michael talked about, we used SQL Alchemy and MySQL client to host the backend in the database. So here's what a finished product of our site looks like. I guess we probably should have included what the previous site looked like. But this is what we came up with. So it's a modular site. There's a couple different functions we can use. So we've included user profiles, so users can sign up and log in. getting access to their own data sets, and gives them access to other functions as well. We have data set and protein cards that allow the users to view data sets and proteins that exist within the site. And then we've also included an admin role, which allows the admin to manage different data and groups and users that also are on the site.
And then to go on top of that, so this is the specific page for proteins. So those are connected to data sets. A data set can have one-to-many proteins. And then on this slide right here, we have the template. So they go through each researcher goes through these steps to upload a data set to the website. First, they can download a template, which offers 2 CSV files that give them some information about the format and what the files should look like. And then they can go to the upload data set page where they can go and open their file manager and navigate to their files that they want to upload. And then finally, that's parsed by PyMongo and displayed back to the user with some broad information about their data set, and then they can click confirm.
So this is just a rough overview of a schema for our backend. One of the challenges we had was we had existing data set that we had to work with, along with creating new tables for our users. A lot of these tables that are shown here are come from the Django framework that we are using. So Django includes user management as part of their framework. So that took a lot of the effort off of us for creating and storing users. Django also takes care of the security aspect of that as well. So most of what is here includes those pre-built Django tables along with what Michael and I came up with for a solution for the dataset storage. And then a lot of the tables that you see at the bottom that don't have relationships were asked to be included by the sponsor as stock data. So the tables at the bottom are actually filled with thousands of lines of information that is available to the researchers. That gives them more information as they're uploading and managing their data.
Okay, and then for development operations, we had an EC2 instance through Amazon Web Services. So this was hosted on the Amazon platform. Then we also had Travis CI for continuous integration and deployment, and Conda for our environment. So we had everything in an environment YAML file that was included all of the dependencies. All right, and then so for some value and highlights, we created a new version of the P3DB site to use for researchers in academia for the next 10 plus years. And highlights, so we can now create users, browse and search through different proteins, and click to see information about those proteins. And researchers can click on the upload page to upload specific data sets.
Awesome. And I guess with that, we will open the floor if there's any questions.